Hey everyone, I hope you're doing well. Welcome back to another video. If you're new to this channel, welcome. Today we'll be going over the basics of the new Mojo language. So if you haven't heard about this language yet, please check it out in the link in the description below. So without further ado, let's get started with some code. So let's get started by talking about how can we write a simple hello world program in Mojo. Well, I already have a file created called languagebasics.mojo. If you want to install Mojo locally, you can reference their documentation. It's very well written. And this video is actually also based on their documentation. However, it's important to note that as of today, Mojo only runs on Linux, but I'm sure in the future it will support Mac and Windows. Okay. So let's just get started. Like other compiled languages such as Java, C++, Golang, or Rust, the main function is often the starting point of the code. So in Mojo, we can define the main function this way with fn, which probably stands for function, which is really intuitive, fn main. And then in here, we can define our code logic. So let's say hello world, and this is how we can run hello. This is how we write hello world in Mojo. So let's see, how can we run this? Well, there are several ways to do this. We could use the run Mojo file in VS Code. There's a Mojo extension you can install in VS Code, or you could also run this through the terminal with Mojo and then the name of the file. But let me first save this. I'm using Vim, and if we run it, we see hello world. Okay, so let's talk a bit more about Mojo. What is Mojo? Mojo is an entirely new language that it's not just Python with newer syntax. Mojo preserves Python's language syntax and dynamic typing features. However, it also supports systems programming features, strong type checking system, which is really necessary to build robust software these days, memory safety features, and newer compiler technologies. And there are just many more features that Mojo has to offer. Like Python, it's designed to be a general purpose programming language. So you can build a variety of different software using Mojo. However, it's likely going to be mostly used for machine learning and AI purposes. So yeah, now let's look at some more Mojo code. So let's talk about type checking, right? So in Mojo, you could define a variable using var, and then let's say x, and then see how we can specify the type. We can specify int here, which is different from Python and JavaScript, where we can't really specify a type. And we can do x plus equal 5, which adds 5 to x. And let's print out the result. Let's save this file, and boom, we get 15, right? So you might notice that Mojo's syntax is relatively similar to Python's. This is because Mojo supports all of Python's syntax and semantics. For example, Mojo also uses these line breaks and indentation to define code blocks, just like Python, which is different from other programming languages like Java or C or C++, which uses curly braces like this, right? Mojo also uses Python's control flow syntax, such as if and for loops, so we can see that. So let's say var x int. Let's define another int, and let's set it to 10 for now. You can actually use semicolons, and it's fine, but I prefer not to. And let's write a simple for loop, 10, and we append I to x. Let's print out x. So you see that this for loop is actually exactly the same as how you write it in Python. And the print function and this line is also the same as Python. So it's really just similar to Python syntax-wise. And let's run this file, and we get 55, which is correct because we're summing from 0 to 9, and we're adding 10 to that sum. So we get 55. Okay. All right. Now let's talk about functions in Mojo. Mojo functions can be defined with fn or def, which is Python. So you might be wondering, what is the difference between them? Well, the fn declaration enforces strongly typed and memory safe behavior. So notice how we're declaring that this variable is an integer. And while Python, you can't really declare the variable type, right? So def provides Python style dynamic behavior, in other words. So we could rewrite our program using def here. Let's do that. Def, and then say x equal 10. Right? This is how it might look in Python code. We won't really have any type declaration here. Okay. So let's change it back. Okay, so you might be wondering, why does typing matter? Well, let's see an example to illustrate this. We can create a new Python file called language basics.py. Okay, and then let's define main function x equal 10, and then we set x equal hello, and let's print x. Let's just do this again. I forgot to save the file. Boom, see, now x is hello, but it was originally defined as an integer. So there is obviously something wrong with that. This isn't very type safe. So this is where fn really shines, right? Let's just delete that file first. Okay. In Python, we could just reassign x to a string. However, if we do this in Mojo, it won't really work. As you can see, we get an error here. We can't reassign it to a string. And that's a good thing if you want to develop robust software. Now let's talk about variables in Mojo. You can declare variables using var, as shown here. This creates a mutable value, which means that you can change the value of x. However, if you want to create an immutable value, which means you can't modify the value, often used when you have a constant that you don't want to modify. For example, gravity, acceleration, right? That's a constant value. You don't want to modify that value. Well, let's see how we can do that. So let's say let gravity, let's say int equal 10. Let's just round it to 10. People are gonna get mad at me and say, no, it's 9.81. But let's just stick to int for now. So let's say it's 10, and this is constant. We use the let keyword here to define it as a constant. If you come from a JavaScript background, you might think that this is super weird because let in JavaScript actually lets you change the value, but in Mojo, this is pretty much constant. Okay, so this is pretty much const, right? Okay. Now let's try to modify this value. See, we can't modify this because it's immutable, right? Okay, I hope you understand. Okay, so what if you don't want to use var or let? Then you'll actually get an error because fn functions require explicit variable declarations, unlike Python def functions. However, do note that the explicit type is not required for variables in fn functions, but it is definitely a good practice to include it for a more robust code. So if you don't include it, Mojo will actually infer the type. So let's see what I mean by that. Let's just say let hello, which is a string, equal hello, and then we let another variable called world, which is, well, let's not declare the type this time, and let's call it world. Right, now if we print hello, let's add a string and then world. Let's save this file and run it. We get hello world. So Mojo actually inferred that the type of this is a string, and this is what. So in this case, you don't actually have to specify the types here. So I hope that was helpful. Now let's talk about function arguments and returns. So types are required for arguments and return values for an fn function here. For example, let's write a simple code for summing two numbers. Let's delete this for now. Let's write an fn function called add that takes in x, y, right? This is how you typically do it in Python, maybe with type annotation, but you see how it says argument type must be specified. Let's just write pass for now. Okay. Sorry, let me write something so that we ignore this here. Oh, I see, it's due to that. Okay. So notice how the fn argument type must be specified. So this is where we specify the type. So let's say int and int, right? In this case, x and y are integers that we're taking to sum them up together. Now the return type must be int, right? We're summing up two values. You can just write return x plus y. And let's call it, right? So let's define var x, which is int, equal 10, and var y, which is an int, and equal 5. And let's print the sum. Let's do that. X, we add x and y, right? Let's save this and run this file. Mojo actually gives you warnings, so we never change the values of x and y, so Mojo suggests us to switch them to let instead, but we can ignore this for now. And we get the sum is 15, which is exactly what we want. So this is why you need type. You need to define the type here, and also the type for the return value for an fn function in Mojo. Okay, cool. Now let's talk about argument mutability and ownership, which is a more advanced topic. So if you don't understand this part too well, don't worry. You can ask any questions in the comment section below and I will try to answer it. Okay, now let's go back to our add function we defined and modify it a little bit. So let's call this double add, and we will do some cool stuff here. X equal 2 and y times equal 2, and we return x plus y, and let's call it double add. So you see that we have an error here. Expression must be mutable for in-place operator destination. Well, this is because the add function doesn't actually modify x or y. It only reads the values of x or y, for example 10 and 5. The fn function arguments are immutable references by default, so you can't really modify the values outside here, so nor inside. In fact, this concept is called borrowing. Although it's default for fn functions, you can still make it explicitly clear that it is a borrowed declaration. So you can let others know that it is immutable. So we can write this borrowed, and this basically is the same as the code without borrowed, but this makes it explicitly clear that x is immutable. And this is a good practice to have. Okay. Now, what if we want to make this mutable? Well, this is where in-out declaration comes in. So instead of borrow, let's do in-out. And we no longer have any errors. And in the meantime, let's also print out x. Print out y. Oops. Okay. Let's run this file. Boom. We get 30, which is 2 times 10 plus 2 times 5, right? However, notice that the value of x and y also changed. X is now 20 and y is now 10, which is double, right? So this is changed because of this code up here. We use the in-out declaration, which is actually really intuitive if you think about it. It just means that the changes made to the arguments inside the function are visible outside the function as well. Now, what if you want to modify the argument inside the function but not outside, right? We don't want to modify these values. Well, this is where the owned declaration comes in, right? The get owned. Let's say owned. Oh my god, I can't spell. And let's also say owned. Okay. And let's save this and run it. We got some warnings here, but we can ignore them because x and y are not modified since we're using own declaration here. So as you can see, x is 10 and y is 5, while the sum is still 30, which is what we want here. In this example here, Mojo actually makes a copy of x and y and passes it as arguments into the double add function we have here. However, note that making a copy of these variables could be an expensive operation for certain types of variables. So if you do not want to make copies of x and y in this case, then you could add the char, which is the transfer operator. So let's see how we can do it. We simply add the char at the end here, and this will no longer create copies of x and y. Let's clear this and run it. Notice how we get an error here. I'm not surprised at all. This is because the transfer operator actually destroys the local variable names x and y. So when we try to print out x and y, they no longer exist anymore. But if we remove the print statement, it should work. Sorry. See, we get 30 and some warnings that we can just ignore for now. So we just talked a lot about different types of argument declarations like in-out, owned, and borrowed. So what is the point of them, right? What is the point of these mumbo jumbo? These argument conventions are designed to provide system programmers with complete control for memory optimization while ensuring safe access and timely deallocation. Okay, so I hope that is clear why we need these. If you're a system developer, this is very good for you. Okay, now let's talk about structures or struct, which you might have worked with if you use C++. So with structures, you can build high-level abstractions for types or objects. And a struct in Mojo is basically a class in Python. That's the way you can think about it. You might have seen this used a lot in C++. So let's see an example of a basic struct. Let's say struct. Let's define a pair, right? And as you can see, this syntax is also really similar to C++. And let's say var first, which is an int, and var second, which is also an int, right? We can just define these here for now. And in the constructor, we'll actually define the values. And we have an init function, which you probably worked with if you know Python. And we have self here, just like Python. And first, which is our argument. And this is an int, and so is second, which is also an int, right? And then we can do self.first equal first, self.second equals second. If you use Java, for example, this is just this.first equal first. So self.first is referring to this value up here, this variable here. And this first is referring to the first here passed in as an argument, as a parameter, okay? And let's define a dump function, fn dump, and we pass in self here, just like Python, right? And we can print out self.first, self.second, which is referring to the variables first and second for this instance variable. And let's define the pair. Let my pair equal pair 10 and 15. Right, so this will define a pair of variables, pair of integers 10 and 15. And then we can print it out with the dump function, my pair.dump. Right, let's save this file and run it. Boom, we get 10 and 15. Okay, so I hope you have a pretty good fundamental understanding for Mojo as a language. You might be wondering, can you run all your Python code in Mojo? The answer is not yet, which isn't no. Some of your code might run while others will not, but probably most of your code will run if it's simple enough. Mojo is working on making Mojo a complete superset of Python, so in the future the answer is yes. You will be able to run all your Python code in Mojo, but at the moment the answer is no. So thank you guys for watching. I hope you found this video to be helpful. If you have any questions, please ask in the in the comment section below. And feel free to reference Mojo's documentation, which is really well written. So you should definitely check it out if you want to explore Mojo further. I will make more videos about Mojo in the future as well, so stay tuned and subscribe if you're interested in this type of content. And yeah, thank you guys for watching. I hope you have a great day. Bye.